For years, Mars had been treated as a silent witness to the history of our solar system, a cold, wind-carved sphere of dust that carried no intentions, no secrets, no signs of anything beyond the slow erosion of time. But the illusion of its stillness shattered the moment scientists uncovered the first unmistakable pattern hidden inside decades of archived telemetry, a pattern that suggested that something had been studying the planet long before humanity ever sent its first rover across the Martian soil. What began as a routine comparison of energy readings from different missions quickly escalated into one of the most unsettling discoveries in the history of planetary science. Subtle but consistent anomalies in electromagnetic background signatures that repeated at intervals too precise to be geological and too stable to be atmospheric. These shifts appeared in data from orbiters separated by generations of technology, captured by instruments that had never been designed to detect anything beyond natural variation. And yet the same rhythmic distortions emerged again and again, always in the same regions, always with the same quiet insistence, as though an unseen system had been sweeping across the planet's surface at regular intervals, patiently, methodically, and without ever revealing its source. The first reaction within the scientific community was disbelief. Mars had been scanned by countless spacecraft over the decades, each delivering enormous volumes of data, and nothing like this had ever been identified. But when analysts synchronized the anomalies across multiple missions, NASA, ESA, Roscosmos, even early Japanese and Indian orbiters, the pattern sharpened into something undeniable. The distortions did not drift. They did not fade. They did not scatter like the echoes of natural processes. They lined up with a precision that could only come from a controlled, repeatable system. And even more alarming, they seemed to target specific regions of the Martian crust areas, rich in minerals, water-altered rock, and ancient sedimentary structures known to be capable of preserving traces of long-extinct life. These were not random sweeps. They were intentional passes. Someone or something had been scanning Mars for a very long time, and they had been doing it with a focus that suggested purpose, interest, and a depth of technological capability far beyond anything humanity had ever deployed. What unsettled the researchers most deeply was not the presence of the scans themselves, but the timescale implied by their consistency. The earliest detectable imprints appeared not in modern satellite archives, but in raw analog records from missions launched in the 1970s, readings dismissed at the time as instrumentation noise. When those early traces were reanalyzed with modern tools, the same signature appeared, unchanged across half a century. This meant the scanning system had been active long before humanity ever touched Martian soil. And because its pattern remained stable across decades of shifting solar activity, orbital variation, and atmospheric thinning, it became clear that the system responsible was not only precise but adaptive, capable of compensating for environmental noise with a level of refinement that left human technology in the dust. The implication was impossible to ignore. Whoever was scanning Mars had been doing so continuously, patiently collecting data, accumulating measurements, and refining their understanding of the planet long before humanity realized there was anything to find. The deeper the investigation went, the more frightening the picture became. The anomalies concentrated not on visually dramatic features like Olympus Mons or Valles Marineris, but on zones known for their subsurface ice deposits, their mineral richness, and their geological potential to preserve organic remnants. Places where traces of past life, if they ever existed, would still linger in chemical shadows beneath the soil. The scans followed these regions with a consistency that suggested evaluation rather than exploration, as though the goal was not to map the planet but to determine something specific about its past, its resources, or its suitability for a purpose humanity could only guess at. And when analysts modelled the sweep patterns across time, they discovered that the intervals aligned not with any natural Martian cycle, but with a rhythm more reminiscent of long-duration reconnaissance systems ones that revisit target zones with clockwork precision. By the time the first reports reached international observatories, the Scientific Council had already reached a single, quiet, terrifying conclusion. Mars had been under long-term, structured observation by an unknown intelligence, not observed casually, not surveyed opportunistically, scanned repeatedly, thoroughly, and with a focus that suggested a search for something very specific, something buried, something preserved, or something valuable. And as that realization settled into the minds of the people who had spent their lives studying the Red Planet, one question became impossible to escape. If they had spent decades scanning Mars, then what exactly were they looking for? Resources, rare minerals, traces of ancient life, or something far more unsettling, something humanity had not yet uncovered, but they already knew was there. What made the discovery even more disturbing was the realization that the scanning signatures observed on Mars were not unique to the planet at all. They matched, with unnerving precision, the same spectral fingerprints later identified in the transmissions of 3I Atlas and N2 SVEN. The same modulation pattern, the same rhythmic intervals, the same faint harmonic echo that had puzzled analysts during the Earth study. It was as if the probe's brief appearance near our world had merely been the final chapter of a mission that had begun decades earlier on the Red Planet. The more the Council compared datasets, the clearer the connection became. Atlas and SVEN had not arrived in the solar system to study Earth. They had arrived to study everything, and Mars had been their first laboratory. When scientists overlaid the Martian anomalies against the reconstructed flight trajectories of Atlas and SVEN, an even more unsettling image emerged. The areas of intensified scanning perfectly aligned with regions that the probes would later map at high precision during their sweep past Earth. It was as though the probes were gathering data according to a hierarchy, starting with the most geologically stable and quiet bodies of the solar system, and advancing step by step toward the most complex and chaotic. Mars, with its thin atmosphere, minimal magnetic shielding and long geological memory, would have been the perfect place for the probes to calibrate their instruments, refine their algorithms and practice long-range subsurface imaging before turning their attention to worlds with thicker atmospheric interference. But as the analysis went deeper, it became clear that Atlas and SVEN were not merely scanning Mars as a training exercise, they were searching for consistency. They returned to the same regions again and again, as though tracking changes over time. They studied the ice caps, the ancient river deltas, the basalt plains where volcanic gases once flowed, and in each of these regions the probe's signatures displayed small but deliberate adjustments in frequency and amplitude adjustments that, when plotted across decades, formed a pattern of iterative refinement, as if the probes were narrowing down their focus with every cycle. Something on Mars was of interest to them, something specific, something they believed was worth watching. And the most unsettling detail was this: the cycles did not stop when Atlas and SVEN passed Earth. They had been active long before the probes revealed themselves, and according to the latest data models, they may still be active today, silent, distant, undetected by all but the most precise instruments. It raised a chilling possibility that the Scientific Council could no longer avoid. Atlas and SVEN were not the beginning of the story. They were simply the first ones we caught. If the probes had been scanning Mars for decades, then the scope of their mission extended far beyond anything humanity had imagined. They were not explorers, they were surveyors, evaluators, machines executing a program so large and so ancient that the arrival near Earth was simply one node in a chain of objectives that included not only Mars but every world touched by the sun's gravity. The scientists began asking themselves a new question, one far more disturbing than anything considered during the Earth investigation. They were no longer wondering why the probes came to us. They were wondering how long they had been here. As the investigation deepened, scientists began to notice patterns in the Martian landscape that no longer looked like the slow work of geology, but like the faint imprints of a long-term external presence. Subtle traces that had been overlooked for decades, simply because no one ever imagined that Mars could have been subjected to repeated precision-focused scanning by something not made by human hands. When analysts re-examined high-resolution orbital photos taken across multiple eras from Viking in the 1970s to MRO in the 2000s, they found features that did not behave the way natural formations should. Thin, linear depressions in the dust that ran too straight and too consistently to be wind erosion. Microscopic shifts in surface reflectivity that appeared and disappeared in rhythmic intervals, matching the periods during which the unexplained electromagnetic anomalies had been recorded. Even the distribution of thermal hotspots around certain mineral-rich regions showed patterns that did not align with seasonal changes or geological vents. Instead, they aligned with the scanning intervals later traced back to the same spectral signature associated with 3I Atlas and N2 SVEN. The more data the researchers compared, the more these so-called natural oddities, converged into a single timeline. Certain patches of regolith seemed to brighten in infrared imagery at regular spans, as if they had been exposed to directed energy bursts powerful enough to momentarily alter their thermal properties. Radar scans that once appeared noisy or fragmented now looked like the blurred echoes of deep penetration pulses, reflections coming from layers far beneath the surface, reaching depths that human radars could not probe with such consistency. These anomalies were not chaotic. They were not scattered randomly. They followed path-sweeping arcs across the crust, converging over regions known for their ancient hydrothermal activity, spreading out across plains where meteorite impacts had exposed rare minerals. With every overlay of the data, it became clearer. Mars had not simply been scanned, it had been mapped repeatedly, methodically, and with a purpose that grew sharper the longer the pattern was studied. One of the most chilling revelations came from analysing changes in dust accumulation across decades. Mars is a planet where thin layers of dust settle constantly, blown by winds strong enough to bury landers, yet certain narrow bands, just meters wide, remained consistently cleaner than their surroundings in every archival image. These zones followed the exact curvatures of the electromagnetic signatures linked to Atlas and SVEN, forming ghostly trails that seemed to whisper of repeated passes, each one sweeping away or disturbing the uppermost dust layers. To a casual observer, these differences were imperceptible, but to scientists who now understood what they were looking for, the alignment was unmistakable. Something had moved over those regions again and again, leaving behind a fingerprint so delicate it had blended into the planet's natural variability until the probe's own signatures revealed the pattern hiding beneath the noise. And then came the discovery that rattled even the most skeptical researchers. In several locations, high-frequency radar images showed faint, perfectly circular voids in the subsurface, dust-thin cavities less than a meter across, spaced at intervals too regular to be accidents. These cavities were not tunnels, not geological pockets, not gas release chambers. They were symmetrical impressions, as though created by momentary bursts of energy that vaporized microscopic amounts of material before dissipating without a trace. And when scientists modeled the energy required to form such cavities, the result matched precisely the output levels inferred from the passing signatures of Atlas and SVEN. It was the first concrete physical evidence that the probes hadn't simply observed Mars, they had interacted with it, leaving behind microscopic scars that the planet's quiet surface had preserved for decades. By the time the analysis was complete, the conclusion was unavoidable. Many of the features long assumed to be quirks of Martian geology were, in fact, silent reminders of an intelligence that had been studying the planet far longer than humanity had been capable of detecting it. The probe's brief encounter with Earth was only the latest chapter in a mission that had unfolded across generations on a world humanity once believed to be untouched. And with every new anomaly that matched their signature, one question grew heavier, darker, and harder to ignore. If they had altered the dust, disturbed the crust, pulsed the subsurface, and mapped the minerals of Mars, then what exactly were they searching for? As the investigation widened from the Martian surface to the thin veil of atmosphere that still clings to the planet, scientists encountered a new category of anomalies. Subtle, almost ghost-like disturbances that had been dismissed for years as instrument error, thermal noise, or the unpredictable turbulence of a world with barely enough air to sustain weather. But when these disturbances were re-examined with the knowledge of Atlas and SVEN's spectral signatures, their patterns sharpened with a clarity that left the research teams silent. The variations did not behave like natural fluctuations in pressure or temperature. They behaved like responses, tiny atmospheric tremors that aligned precisely with periods during which the scanning signatures were detected. Mars, despite its thin atmosphere, was reacting to something passing through it, something that moved with a precision and rhythm that could not be explained by wind or dust storms. At first, the distortions looked random, but over time they fell into a sequence, matching the sweep cycles later attributed to the same unknown probes. The most telling evidence came from data collected during the global dust storms that periodically engulf the planet. During these storms, visibility drops to near zero, and even the most sensitive instruments struggle to capture clean readings. Yet buried in the noise of these tempests were pulses brief, consistent, and far too structured to be natural, appearing as evenly spaced disruptions in atmospheric density. These pulses mirrored the exact interval patterns encoded in the low-frequency emissions linked to Atlas and SVEN. Even more disturbing was that the pulses intensified over certain mineral-rich regions, as though the atmosphere itself was being used as a transmission medium or feedback layer for whatever technology had been sweeping the planet. When scientists layered decades of storm data over known geochemical maps of Mars, faint corridors of atmospheric displacement became visible paths that matched, with almost painful precision, the ground-level anomalies previously discovered along the planet's surface. The atmosphere and the crust were responding to the same intrusions. What shocked analysts further was the discovery of warm atmospheric pockets regions, barely a few kilometers wide, that recorded sudden, localized temperature spikes before dissipating as though they had never existed. Mars does not generate heat this way. It lacks the volcanic activity, the tectonic friction, the thick atmosphere required to trap warmth. Yet these pockets appeared repeatedly near subsurface ice deposits and ancient riverbeds, precisely where a scanning system interested in water, minerals, or biological traces would focus. At first, these anomalies were dismissed as solar reflections or errors in infrared calibration. But when the timestamps were compared with the signature cycles associated with the probes, the match was undeniable. The spikes lasted only seconds too short to be geological, too frequent to be random, too clean to be accidental. Something had passed through those regions, disturbing the atmosphere with controlled bursts of energy. Even the behavior of dust itself, Mars's most abundant atmospheric component, revealed the same story. High-speed imaging showed dust columns twisting upward in narrow spirals that did not correspond to the direction of wind flow. These spirals formed only in regions associated with the deeper subsurface anomalies documented earlier, rising as though drawn upward by something moving through the thin air, like the wake of a silent machine or the afterimage of a pulse that had passed moments earlier. Over multiple decades, these dust anomalies repeated with a consistency that no natural Martian process could sustain. When researchers modelled the required energy levels for such vertical disturbances, the numbers lined up with the estimated output of the scanning pulses attributed to Atlas and SVEN. The dust was not rising on its own, it was reacting. In the end, what had once seemed like random atmospheric noise revealed itself as part of a coordinated pattern, a reaction chain that stretched from the planet's surface through its air and into its orbit. Mars had been quietly trembling under the influence of an intelligence that had passed through its skies so many times that the atmosphere had adapted to their presence, imprinting the faint echoes of their movement like scars left behind by the wings of something that had flown too high, too quietly, and for far too long. The probes had not simply observed the Martian surface, they had penetrated its sky, carved paths through its dust, sampled its air, and mapped the silence above a world that had no reason to believe it was being watched. And as the pieces fit together, one truth became impossible to avoid. Whatever scanned Mars did not need a thick atmosphere to leave a mark, it only needed time. As soon as scientists turned their attention below the Martian surface, the entire investigation shifted from unsettling to profoundly disturbing. For decades, subsurface radar data from different missions, Marsis, Sharad, early Soviet radar experiments, even fragments of analog telemetry from the 1980s, had contained strange, inconsistent reflections known informally as ghost echoes. Originally, these anomalies were attributed to instrument glitches, variations in ice content, or reflections from layered rock formations. But when researchers synchronized these echoes across missions and aligned them with the atmospheric and surface anomalies previously identified, a chilling realization emerged. The ghost echoes were not geological quirks, they were shadows, faint, structured, rhythmic shadows generated by pulses that had penetrated deep into the Martian crust, pulses that matched with unnerving precision the energy signatures associated with 3I Atlas and N2 SVEN. The probes had not merely scanned the surface, they had reached down into the planet's interior, leaving behind patterns that no natural process could recreate. The radar distortions followed a logic that felt almost surgical. They traced subsurface ice sheets, ancient aquifers, sedimentary pockets and mineral-rich veins with a degree of accuracy that human instruments had only confirmed decades later. In certain regions, particularly around the southern polar layered deposits, the echoes formed long, narrow corridors where the radar beam behaved as though it had encountered something already disrupted, as if the soil had been briefly energized or thinned by a prior scan. These emptied pockets were too symmetrical, too shallow, and too repetitive to be natural. Their shapes followed the same parabolic arcs identified in the atmospheric pulses and the dust disturbances, forming a continuous chain of evidence that suggested a scanning system capable of probing kilometers beneath the surface with almost no loss of resolution. Even more alarming was the repeated appearance of what analysts began calling moving shadows echoes that shifted position across years of archived data, despite the fact that the rocks and ice they appeared within could not possibly have changed. These shadows were not objects. They were voids, temporary reductions in radar reflectivity that travelled slowly across subsurface maps as though tracking the memory of something that had passed through. When these shadow paths were plotted, they formed smooth trajectories that mirrored the sweep lines identified in earlier surface anomalies. The conclusion was unavoidable. The probe's energy pulses had not only penetrated deep into the ground, but had done so repeatedly, tracing lines through the crust that left behind faint signatures, detectable only when viewed across decades of data. One region in particular, an ancient basin rich in hydrated minerals, displayed a pattern that stunned the research teams. Beneath its surface lay a faint spherical zone, perfectly smooth, perfectly hollow in its radar profile, too geometrically flawless to be anything but artificial. This cavity was only visible in data from certain years, appearing and disappearing like a ghost, but always with the same diameter and the same clean boundary. It was as if something had temporarily altered the ground there, heated it, ionized it, or displaced it through a scanning method that left no lasting physical structure, but imprinted a lingering radar signature. When modelling software attempted to replicate such a profile, the only plausible explanation was a high-intensity energy pulse, one strong enough to cause temporary separation in fine-grained sediments without collapsing the surrounding layers. No human instrument sent to Mars had ever been capable of anything remotely similar. But the deepest shock came when analysts correlated these subsurface anomalies with spectral data collected from orbit during the same periods. They discovered faint traces of mineral disturbance, subtle changes in reflectivity that suggested exposure to short bursts of electromagnetic energy. The wavelengths of these bursts matched the lower frequency harmonics associated with Atlas and SVEN, confirming that the probe's technology was not only capable of penetrating the ground, but also of altering the chemical behavior of minerals at depth. In some regions, these disturbances were concentrated around ancient lakebeds areas where liquid water once flowed, and where, if life had existed on Mars in the distant past, its chemical remnants would be most likely to survive. This forced the Council to reconsider the purpose behind the scans. These were not random, deep probing sweeps. These were targeted intrusions into geological environments capable of preserving the history of life. The probes weren't simply mapping the crust, they were interrogating it, extracting its secrets, examining the memory of a world that had been dead for billions of years. Mars, it seemed, was not just a planet of interest. It was a vault of minerals, of ice, of chemical signatures, and possibly even traces of ancient biology. And now that the shadows beneath its surface had been reinterpreted, one haunting question grew impossible to ignore. If they searched this deeply, if they scanned through dust, rock, ice, and time itself, then what exactly did they hope to find buried beneath the red planet's frozen silence? As soon as scientists broadened their scope beyond Mars and began comparing its anomalies with archived data from other bodies in the solar system, the investigation crossed a threshold from unsettling to horrifying. Patterns that once seemed unique to the red planet's strange atmospheric pulses, surface micro-disturbances, deep radar shadows and rhythmic electromagnetic signatures began appearing in places where no such processes should exist. Tiny echoes embedded in ice-penetrating scans of Europa, faint resonance lines in the geysers of Enceladus, micro-distortions in magnetometer data from Mercury's barren surface, and most disturbingly of all, subtle, long-overlooked anomalies recorded in seismic reflections from the Moon, our own Moon during the Apollo era. At first, these similarities were dismissed as coincidences or artifacts of faulty equipment, but when analysts overlaid the spectral fingerprints of 3I Atlas and N2 SVEN onto these historical datasets, each anomaly snapped perfectly into place, the same patterns, the same intervals, the same technological accent hidden in the noise. It was as if the entire solar system had been quietly brushed by the same invisible hand, long before humanity knew what to look for. Europa's data was the first to crack the illusion of isolation. Buried deep within decades of ice-penetrating radar logs were faint, repeating distortions that did not align with the slow, natural movement of its subsurface ocean. These distortions were controlled, consistent, and appeared only in regions where salt content and thermal activity suggested the presence of complex chemistry, precisely the kind of zones an advanced intelligence would target if it were searching for biological potential. The anomalies on Enceladus told a similar story. Tiny, rhythmic shifts occurring at the edges of the moon's cryovolcanic plumes, as if something had passed through those regions, sampling the material before it ever reached space. In both cases, the anomalies were decades-old, recorded by missions long forgotten, preserved in data that had never been reanalyzed with the knowledge provided by the recent encounters. Mercury's anomalies were harder to explain. Its surface is battered, ancient, and baked by the sun, hardly a place anyone expected to find signs of precision scanning. Yet its magnetometer logs contained faint harmonic distortions that matched the lowest frequency signatures of Atlas and SVEN. The distortions appeared only near certain mineral deposits regions where rare elements formed in the planet's violent early history. Scientists had no explanation for this kind of selectivity, unless the scans were not environmental at all, but deliberate probes searching for specific materials that might be rare on a galactic scale. But nothing startled the research community more than the data recovered from the moon. During the Apollo missions, astronauts placed seismometers across the lunar surface. For decades, those instruments recorded events ranging from meteor impacts to thermal cracking. But hidden in those old records were short, sharp seismic signals, micro-tremors that no one could explain because they did not behave like impacts or natural moonquakes. They came at intervals too regular for coincidence, too gentle to be geological, and too brief to originate from beneath the surface. When these tremors were compared with the estimated scanning frequencies attributed to Atlas and SVEN, the correlation was nearly perfect. Something had passed through lunar orbit in the late 1960s and early 1970s, something that generated vibrations in the regolith matching the energy pulse patterns now associated with deep crust scanning on Mars. Piece by piece, it became clear Mars was not an isolated target. It was part of a chain, a long, quiet survey that had included icy moons, rocky planets, and even Earth's own satellite. The solar system had been scanned comprehensively, and Mars, with its accessible surface, rich geological memory and remnants of ancient water, had been the ideal starting point. But the larger implication was far more unsettling. If Atlas and SVEN were simply the first probes humanity had detected, then their presence near Earth was not the beginning of observation. It was the confirmation of a process that had been underway for decades, perhaps centuries. They were not visiting a new system, they were revisiting one. And as this realization took shape, a chilling question began to haunt every researcher involved. If Mars and the other worlds had been scanned long before the probes revealed themselves near Earth, then how many times had they passed by without us noticing? And more importantly, what are they preparing for? When the Scientific Council finally overlaid all the Martian anomalies onto detailed geological maps of the planet, the pattern that emerged was so precise and so intentional that it erased the last doubts about the probe's objectives. The scans were not distributed randomly across the surface. They did not follow the logic of simple mapping, nor the curiosity-driven paths of exploration. They traced specific regions with surgical accuracy, aligning with mineral clusters, ancient waterbeds, hydrothermal residues, and sediment layers known to preserve chemical signatures of life. What the probes targeted were not landscapes. They were resources. Not shapes, but compositions. Not mysteries, but potential. And the more the maps were synchronized, the clearer the picture became. Whoever scanned Mars had been searching for something rare, something valuable, something that might exist only in worlds with a very particular geological past. The first layer of this pattern lay in Mars's mineral deposits. The scans repeatedly intersected regions rich in boron, yttrium, and unusual concentrations of beryllium elements that are scarce across planetary crusts and often associated with ancient hydrothermal systems. These minerals form only under specific conditions, the presence of heat, water, pressure, and time. Their appearance on Mars suggested a complex geological history that had once supported flowing water and chemical gradients, conditions ideal for life as humanity understands it, and potentially ideal for extracting resources that could serve advanced technologies. Even more telling was the probe's repeated focus on manganese-rich formations, whose oxidation states require not just water, but a strong oxidizing agent, something Mars should not have produced on its own, unless biological processes once influenced its chemistry. But minerals were only the beginning. The scans traced ancient deltas and lakebeds places like Jezero Crater and Gale Crater regions, where sediment layering preserved billions of years of environmental history. The probes revisited these zones with unnerving consistency, as though comparing changes across decades or checking whether the chemical markers within the soil had shifted. Their attention to these sites surpassed the interest shown even by human missions, which had spent years analysing them with rovers. The probes, in contrast, appeared to gather signatures from depths far beyond anything terrestrial instruments could reach, penetrating layers untouched since the planet's earliest epochs. If any traces of ancient microbial life still existed on Mars, they would be found in exactly these regions, and the probes had scanned them over and over again. Yet the most alarming part of this pattern was not the geological precision, but the selective targeting. The probes ignored large areas of Mars with dramatic terrain volcanoes, canyons, dune seas. They showed no interest in visually impressive landmarks. Their focus remained locked onto zones where three conditions overlapped: mineral rarity, water-altered chemistry, and sediment capable of preserving biological signatures. It was as though the probes had a checklist criteria for identifying planets with remnants of habitability, or perhaps planets with materials essential to their technology. Whether they were searching for life, for resources, or for something even more specific, their behaviour followed a logic that felt unmistakably clinical. When analysts extended this model to the anomalies found on Europa, Enceladus and Mercury, the pattern strengthened. The probes had focused on the salts and organics in Europa's ice cracks, the hydrogen-rich plumes of Enceladus, the rare mineral belts on Mercury. Everywhere they went, they targeted scarcity things difficult to form, harder to preserve, and potentially invaluable to civilizations that rely on them. Mars, being both mineral-rich and geologically quiet, was the perfect repository, a vault of everything a surveyor might hope to find. This realization forced the Council to consider a possibility far more unsettling than simple reconnaissance. The probes were not studying Mars for its scenery or its past, they were evaluating its worth. They were searching for rare signatures across multiple worlds, collecting samples of chemical potential, mapping distributions of elements, and scanning for signs of ancient biology. And the deeper the Council looked, the more frightening the implication became. They were not looking for life itself. They were looking for the places where life could have been, which also happened to be the places where certain rare minerals accumulate. It meant the probes were not explorers. They were auditors, evaluators, surveyors on behalf of something far larger. And as that truth settled in, a darker question rose to the surface. If they have spent decades searching for these rare signatures, then what happens when they find them? When scientists attempted to model the behaviour of the unknown scanning system, its timing, its cycles, the pace of its revisits, and the way its signatures evolved over the decades, they uncovered a pattern so deliberate and so carefully structured that it no longer resembled reconnaissance at all. It resembled procedure. A tightly controlled, multi-stage workflow executed with machine-level precision, repeating at intervals too consistent to be the byproduct of orbit, drift, or chance. Every anomaly, every pulse, every pass over Mars fit into a timeline that behaved like a program, something designed, something scheduled, something following an internal logic that ignored the natural rhythms of the solar system and instead imposed its own. The probes were not improvising, they were not reacting, they were following instructions. The discovery began with a simple observation. The scans on Mars occurred in cycles. These cycles did not match Martian seasons, solar wind fluctuations, or orbital geometry. They followed a rhythm of their own, one that repeated approximately every 17.9 months, with slight variations that appeared not random but adaptive. In some cycles, the scans lasted longer, in others they focused more intensely on certain regions, as though the system responsible was adjusting to the results of previous passes. This adaptive pattern grew clearer when analysts created long-range simulations, each cycle built upon the last, refining the precision of the pulses, narrowing the scanning corridors, and increasing the density of data collected from regions that had shown geological or chemical promise. It was as if Mars was undergoing a series of periodic evaluations, check-ins, updates, status reports, like a patient being examined by a physician who returned routinely to monitor the progression of something only it understood. And then, there was the modulation shift. Over decades, the energy profile of the scans changed slightly, gradually, but unmistakably. The earliest signatures were broad and unrefined, sweeping large regions with coarse resolution. By the mid-1990s, the pulses had grown narrower, deeper, and more complex, capable of penetrating layers that earlier scans had barely reached. By the 2010s, the probe's pulses appeared optimized, calibrated specifically for mineral and chemical targets humanity only later identified. This progression made one fact impossible to ignore. The scanning system was learning, it was improving, and its evolution was not random. It mirrored the behavior of a process that updates itself based on prior results, refining its capabilities with each iteration. But the most unsettling breakthrough came when analysts compared the timing of the scans on Mars with anomalies found on other worlds. The scans on Europa and Enceladus occurred almost exactly halfway between major Martian cycles. The anomalies on the Moon and Mercury aligned with the transitional phases between deep scan periods. And the appearance of Atlas and SVEN near Earth matched perfectly, with a projected peak in the scanning cycle 1 that implied a shift from quiet surveying to something more direct. It became clear that the probes were not isolated entities acting independently. They were nodes in a larger network, each fulfilling a specific task within a synchronized schedule. Mars was just one checkpoint. Earth was another. The icy moons were data points. The entire solar system was part of a grid-mapped, sampled, evaluated, and revisited according to a logic humanity had only begun to recognize. This realization shattered the last illusion that the probes had wandered into the solar system randomly. Their path was not a trajectory, it was a route. Their actions were not observations, they were instructions being executed. And the cycles they followed were not dictated by gravity or convenience. They were dictated by a mission plan that existed long before humanity was capable of noticing it. The Council eventually reached a conclusion that left the room in silence. The scanning system behaved like an autonomous, long-duration survey mechanism designed to study not a single planet, but entire star systems. Its cycles resembled the operational patterns of something far older, far larger, and far more structured than anything humanity had encountered. It had no urgency, no hesitation, no deviation. It simply worked relentlessly, quietly, with a rhythm that suggested the existence of a timescale far removed from human life. And as this understanding settled into place, an even darker question emerged. If these cycles are still active, then the next phase of the mission is already on its way. As researchers shifted their attention to the thermal history of Mars, they uncovered one of the most unsettling patterns yet subtle, localized temperature anomalies that appeared throughout decades of infrared imaging, each one too small to be classified as a geological event, too brief to be atmospheric, and too precisely placed to be natural. Mars is a cold, thin-aired world where heat disperses rapidly and predictably. Nothing on its surface produces sudden warmth except sunlight and the occasional meteorite impact. Yet in multiple regions, especially those rich in minerals, ice, or ancient water chemistry scientists found abrupt, needle-thin temperature spikes rising and falling in perfect sync with the cycles linked to 3I Atlas and N2 SVEN. These were not the broad, slow thermal shifts caused by solar heating. They were pinpoints, footprints, the lingering afterglow of something that had touched the surface for mere seconds before disappearing again. The earliest of these anomalies dated back to the Viking era. Old infrared readings from the 1970s contained moments where the ground warmed by several degrees in a pattern too uniform to be solar and too localized to be geological. At the time, mission engineers blamed calibration issues, dust contamination, or instrumentation drift. But the anomalies repeated same location, same duration, same temperatures. Later, during the Mars Global Surveyor mission, the same hotspots appeared again, but this time with higher resolution. A narrow streak of warmed regolith stretching across a mineral-rich plain, a circular ring of heat blooming briefly near a dried riverbed, a razor-thin line of elevated temperature crossing a region of subsurface ice. None of these had geological explanations, and when the anomalies were mapped onto the scanning corridors attributed to the unknown probes, they matched perfectly like heat shadows left behind by something moving across the planet with deliberate precision. The breakthrough came when scientists analyzed nighttime thermal inertia, how quickly the ground cooled after sunset. Certain regions that had shown transient heat spikes also cooled at unnatural rates, as though the heat had not come from within the soil, but had been deposited onto it, and then dissipated rapidly. The rate of cooling resembled the dispersal pattern seen when high-frequency energy interacts with granular material, precisely the kind of effect expected if a scanning pulse brushed the surface with concentrated electromagnetic force. In some areas, the ground cooled so quickly that the heat spike left only a faint thermal memory, detectable only by comparing thousands of consecutive frames. And every one of those subtle memories followed the same arc-like paths found in previous atmospheric and subsurface anomalies. Even more alarming were the hotspots detected near ancient lake beds. In these areas, the heat spikes were stronger and lasted longer, as though the probing mechanism was focusing more intensely, perhaps attempting to penetrate deeper or extract more detailed chemical information. Scientists noted that these hotspots often coincided with increases in detected methane-tiny, transient plumes that had puzzled researchers for years. Were the probes triggering the release of trapped gases? Were they reactivating old sediments? Or were they scanning for organic residues that might lie hidden beneath the desiccated surface? Whatever the purpose, the alignment was too precise to ignore. Whenever methane increased, a heat anomaly appeared nearby shortly before or after. It was as if the probes were evaluating the biological potential of Mars in real time, reacting to every hint of chemical activity that might suggest life past or present. But the most chilling discovery came from the polar regions. Near the edges of subsurface ice sheets, thermal imaging revealed repeated microbursts of heat, tiny flashes that lasted only milliseconds, but appeared across decades of data like the blinking of an eye. These bursts were far too sudden to be natural. Infrared sensors recorded narrow circular zones warming by just fractions of a degree before snapping back to their usual cold silence. When these microbursts were plotted over time, they formed spiraling patterns, indicating that something had scanned the ice in a widening helix, as though drilling for information not with a tool but with pure energy. The conclusion that emerged from this collection of thermal anomalies was simple, terrifying, and undeniable. Something had been touching Mars, something that generated heat not through friction or fire but through precision, something that swept across the surface in cycles, probing the crust, the ice, the minerals and the chemical signatures with a consistency that only advanced technology could achieve. And as thermal imaging from later missions began to show the same patterns, repeating long after Atlas and SVEN had passed near Earth, one realization took hold across the scientific community. The probe's visit to our planet was not the beginning of their work. It was a continuation. Mars had been their laboratory for decades. Earth was simply their next step. When scientists finally turned their instruments and algorithms toward the deepest layers of Mars beyond the dust, beyond the fractured basalt, beyond the ancient sediments, a pattern emerged that shattered any remaining illusion that the planet's subsurface was untouched. Radar profiles, once written off as noise or poorly mapped reflections, formed structures that were too symmetrical, too clean, and too persistently repeated across missions to be geological. Beneath certain regions of Mars, particularly the sites that aligned with the probe's scanning cycles, researchers found long, faint, linear voids that cut through layers of rock with a smoothness no natural force could replicate. These voids were narrow, uniform in width, and ran for kilometers, tracing paths that mirrored the trajectories of the pulses attributed to 3I Atlas and N2 SVEN. They were not tunnels. They were not caves. They were tracer lines, deep fingerprints of energy that had passed through the crust, left its imprint for a moment in time, and vanished long before any human instrument could detect the cause. The depth at which these anomalies appeared defied geology. Some were found 20 meters below the surface, others at 200, and a few extended down nearly a kilometer far beyond the reach of normal erosive processes. Mars does not have tectonics. It has no active volcanic conduits carving new paths. It has no underground rivers reshaping rock. And yet these voids were real, detectable across multiple radar systems, from low-frequency sweeps in the 90s to the ultra-precise subsurface mapping done in the last decade. Their shape was unmistakable, parallel-sided, sharp-edged, uninterrupted by the fractures and irregularities one would expect in planetary crust. When analysts reconstructed them in 3 dimensions, they resembled the trail of something that had passed through solid rock without displacement. like the path left behind by a scanning pulse so powerful it temporarily altered the density of the material it touched. Even more disturbing were the circular anomalies, perfectly round cavities only a few meters wide but always identical in spacing and depth, as though stamped into the subsurface by a repeating pattern. These cavities appeared in clusters, each cluster forming a grid-like arrangement aligned with the mineral-rich zones previously identified on the surface. Some clusters coincided with ancient hydrothermal deposits, others with subsurface ice pockets, and still others with the buried sediments where traces of carbon compounds had been detected. The cavities never connected to one another, never branched, never varied in size. They were signatures markers left behind by a scanning mechanism repeating the same process over and over again. When researchers modelled the energy required to produce such uniform voids, the numbers matched exactly the lower energy thresholds suspected in the probe's subsurface sweeps. It was the first time the deep data agreed perfectly with the atmospheric, surface and thermal anomalies. But there was another, far more alarming layer. In several regions, particularly those with ancient sedimentary formations, radar waves returned echoes from structures that seemed to shimmer, not literally, but mathematically. The reflections changed depending on the angle of observation, almost as if the material had been temporarily reorganized at the microscopic level. The soil appeared normal to optical imaging, but radar revealed a strange pattern. Microscopic alignment of mineral grains, the kind of rearrangement that could occur if a high-frequency energy field swept through the ground in a controlled direction. These shimmering zones lined up perfectly with earlier anomalies, dust trails, atmospheric pulses, thermal hotspots, forming a multi-layered chain of evidence that the probes had scanned the planet not just broadly, but repeatedly, refining their examination with every pass. And then came the anomaly that turned the room silent. A perfectly spherical subsurface structure nearly 40 meters across, located in a region where no volcanic or impact activity could justify its existence. The sphere was not hollow, but denser in the center, as though something had compressed material inward without fracturing it. No natural process on Mars could produce such a form, let alone one that appeared, weakened, and then faded from the radar profile over a span of decades. When its pattern was analysed, it matched what the probes might create if they concentrated their scanning energy to a single point, either to examine something deeply buried or to confirm the results of earlier sweeps. The conclusion, after months of analysis, was chilling in its simplicity. The probes had not just scanned Mars, they had examined it with a level of detail far beyond anything human science had imagined, leaving behind structural signatures deep in the crust. These were not scars of extraction, nor signs of construction. They were diagnostic imprints. Mars had been treated like a specimen, its surface, atmosphere, an interior probed with precision that suggested a long-term multi-phase study. And once scientists understood this, a darker question arose, one they had tried to avoid since the beginning. If this is how deeply they scanned Mars, then what exactly were they expecting to find beneath the surface of a dead world? As the Scientific Council continued to trace the probe's scanning paths deeper into the Martian past, one truth emerged with growing clarity. Whatever intelligence had been examining the planet was not simply interested in minerals or geological composition. Their focus aligned with something far more specific, far more meaningful, and far more disturbing Mars's biological potential. Not its present biology, for the planet is barren today, but the echoes of its ancient life. The regions the probes targeted most frequently were exactly those that preserved the chemical fingerprints of a world that once held water, warmth, and the fragile ingredients of habitability. These were not random sweeps. They were autopsies of a long-dead ecosystem. It began with the ice, subsurface glaciers near the poles, ancient frozen reservoirs buried under layers of dust and sediment, showed patterns of repeated scanning that went deeper than anywhere else on the planet. Thermal anomalies, radiometric distortions, subsurface shadows, all converged on ice-rich zones where traces of organic molecules had been detected by human missions only in the last few years. But the probes had scanned those regions decades earlier, long before humanity even suspected that such organics existed. Some of the oldest data showed faint spectral shifts that now aligned perfectly with zones containing chlorides, sulfates, and carbonates minerals formed in the presence of ancient water, and where water once persisted, life might have existed. The probes seemed to know this before humans did. The pattern intensified around ancient lake beds, Jezero Crater, Gale Crater, Ebersweld. These locations, once dismissed as unremarkable, became global headlines when rovers discovered sediment layers that hinted at ancient microbial ecosystems. But long before Perseverance or Curiosity arrived, the probes had traced these very same areas with obsessive consistency. Their deep pulses targeted the sediment layers where hydrated minerals had accumulated. Their atmospheric disturbances aligned with the boundaries of once-flowing river deltas. Their heat spikes coincided with clay formations that had formed in warm, wet environments. If one was searching for the preserved remains of ancient biology, these would be the prime targets. And then came the methane. For years, the scientific community debated sporadic methane spikes detected in the Martian atmosphere brief, erratic plumes that appeared and vanished without explanation. Methane is a fragile molecule. It does not survive long under Martian conditions. Its presence, even in tiny quantities, hints at either active geology or biology. But whenever methane readings surged, another, more subtle pattern appeared in the data. A faint scanning signature, the same spectral echo associated with the unknown probes. The timing was too precise to ignore. The spikes happened shortly after the scans or just before them, as though the scans either triggered the release of methane from buried pockets or specifically targeted regions where its traces lingered. It was in these methane-rich zones that the most unsettling anomalies were discovered. Subsurface radar showed faint layered structures containing trapped gases. Thermal readings revealed the same spiral-shaped patterns previously seen near ice deposits. And in some cases, the dust itself behaved strangely, lifting and falling in narrow spirals when no wind was present. These anomalies were not geological processes. They were responses to pulses passing through the ground, disturbing ancient sediments that had remained sealed for millions of years. The probes had been testing these regions, examining their chemical signatures and evaluating their biological potential with a precision that human science had only recently begun to match. But the most alarming evidence surfaced when researchers analysed the faint organic signatures found in sediment cores collected by rovers. These traces, complex carbon molecules and fragments of ancient biochemical patterns were concentrated in the exact areas where the probes had focused their deepest subsurface scans. The alignment was perfect. Too perfect. It implied that the probes knew exactly where to look for organic residues, not because they stumbled upon them, not because their scans detected faint hints of life after arrival, but because their scanning cycles had been mapping Mars long enough to know, with certainty, where the remnants of ancient biology would be found. This realization forced the Scientific Council to confront the most unsettling possibility yet. The probes were not searching for life. They were checking on it, verifying its past, confirming its extinction or its persistence. Mars, after all, was once a planet with running water, thick atmosphere, and perhaps microbial ecosystems. If any world in the solar system would attract the attention of an intelligence searching for biological signatures, it would be Mars. And the probe's patterns matched the behaviour of a system not merely studying a dead world, but evaluating the remains of a once living one. And as this understanding settled across the Council, one question began to haunt every conversation. If they searched Mars for the traces of life that vanished long ago, what will they do when they find those same traces still active on Earth? The deeper the investigation went, the clearer it became that Mars had not been chosen at random. The probe's long-term focus on the red planet followed a logic so clean, so systematic, and so ruthlessly efficient that it revealed the chilling sophistication behind their mission. Mars was not the closest world, nor the warmest, nor the most stable. But it was the perfect starting point, a world that preserved its history with a clarity no other planet could offer. A world stripped of atmospheric noise, geological chaos, and biological interference. A world frozen in time. For an intelligence seeking to understand the origins, evolution, and extinction of planetary environments, Mars was the ideal first page of the solar system's archive. The planet's thin atmosphere made it an open book. Unlike Earth, whose dense air scatters signals, absorbs energy and distorts readings, Mars allows scanning pulses to slice through its sky with almost no resistance. Every disturbance, every whisper of energy, Every anomalous frequency leaves a clean imprint across the surface. For technology like that of 3i Atlas and R2 SVEN, this made the planet a primitive laboratory one where their instruments could calibrate themselves without interference, refining their scans until they achieved perfect clarity. If the probes were adjusting their methods over decades, Mars was where those adjustments began. Then there was the matter of geology. Mars lacks plate tectonics, the restless movement that erases Earth's history every few 100 million years. Instead, the Martian crust is a static vault. Ancient lake beds, river deltas, and mineral deposits lie exactly where they formed billions of years ago, undisturbed and perfectly fossilized. This geological stillness meant that any trace of past environments, water chemistry, thermal systems, organic residue remained preserved in predictable, untouched layers. For a long-duration scanning system, Mars was a treasure trove of uncorrupted information. And this stillness extended to the planet's magnetic environment. Earth's magnetosphere is powerful, chaotic, and constantly shifting, creating a storm of electromagnetic interference that complicates deep scanning. Mars, however, lost its global magnetic field billions of years ago. Its surface is quiet. Its electromagnetic landscape is clean. Signals pass through it like ink through water. This absence of magnetic interference made Mars uniquely compatible with the probe's deep penetration pulses. The echoes returned sharper, deeper, and with better resolution than they ever could on Earth. But perhaps the most compelling reason the probe started with Mars was its biological ambiguity. Mars once had oceans, rivers, warm climates, and possibly microbial life. It sits on the threshold between habitability and desolation, a world that experienced the conditions for life, then lost them. For a surveying intelligence, such a planet is invaluable. It lets them study the entire arc of biological possibility, how life emerges, how it persists, and how it dies. Mars held the fossilized remnants of a biosphere's rise and fall. If you wanted to understand life in a star system, not just where it exists now, but where it existed before, you would begin with Mars. And this was the detail that unsettled the Council the most. The probes did not begin their evaluation of the solar system with Earth, the living world, the noisy world, the chaotic world. They began with Mars, the silent world, the archived world, the world whose past could be read like a book. Only after they had dissected Mars, its minerals, its ice, its atmospheric remnants, its chemical scars did they expand their scans to other worlds. Mercury, Europa, Enceladus, the Moon. Earth was the last step, not the first. A final comparison, a point of reference. This sequence shattered humanity's self-perception. We had always assumed that if an intelligent force ever visited our solar system, it would come straight to Earth, drawn to the complexity and abundance of life. But the probes followed the opposite pattern. They avoided the noise. They avoided the living world. They started where the story was easiest to read, on a dead planet that preserved its history with brutal honesty. Once they understood Mars, they would understand the solar system's potential. Once they understood the solar system, they would understand Earth. Mars was the foundational layer of a much larger evaluation, an evaluation that placed Earth at the end of the sequence, not the beginning. And as that order became clear, a chilling idea emerged. If Mars was the prologue, Earth is the conclusion. When the Scientific Council finally compared the probe's long-term patterns on Mars with their brief but intense activity near Earth, the contrast was stark enough to reveal something deeply unsettling about our planet's place in their mission. Earth, for all its richness, was not scanned first. It was not the primary target. It was not even an early checkpoint. To an intelligence capable of mapping entire worlds with surgical precision, Earth was a difficult, noisy, unstable environment, one that resisted clean measurements, distorted incoming signals, and constantly reshaped itself through biological, atmospheric, and geological chaos. If Mars was an open book, Earth was a storm of overlapping voices, each one trying to drown out the next. And the probes, whatever their purpose, seemed to prefer silence before they approached sound. The Earth's atmosphere alone made scanning exponentially harder. Dense, wet, turbulent, saturated with molecular activity, it scattered signals like mirrors bouncing light in unpredictable directions. Weather systems shifted hourly, cloud formations absorbed and refracted energy, storms churned electromagnetic fields. Even the simplest deep penetration scan would have been smeared, distorted, or lost entirely. Compared to Mars's thin, quiet envelope, Earth's air was a roaring ocean of interference. The probes did pass through it, but only briefly, and only at the final stage of their mission. They did not spend decades circling Earth, refining their scans, calibrating their tools. They reserved that level of scrutiny for the quiet worlds. The planet's magnetosphere made things even more complicated. Earth's magnetic field is powerful, asymmetric, constantly shifting under the influence of solar wind and internal convection. It generates a complex shield of charged particles that can disrupt, bend, or even erase certain types of signals. To the probes, this would have been a barrier, a thick fog blocking their deepest pulses. In contrast, Mars's extinguished magnetosphere offered a clear window straight to the planet's core. Europa and Enceladus had thin atmospheres and stable magnetic environments. Even Mercury's chaotic magnetic field was easier to pass than Earth's. Only Earth presented a shield so dynamic that scanning it in detail required either extreme precision or a deliberate choice to avoid protracted observation. But the single greatest source of interference was life itself. Earth's surface is alive with electromagnetic noise, human technology, natural biological currents, radio emissions, thermal signatures, chemical reactions, and the constant, endless hum of activity. Life produces chaos. It produces unpredictability. It produces noise that can mask or distort the subtle signals an intelligence might use to evaluate a world. Mars, on the other hand, offered clarity. A dead planet preserves its past. A living planet hides it beneath motion. The probes, following a logic far older and colder than ours, chose clarity first. They learned the baseline before they approached the exception. This difference in scanning behavior revealed a breathtaking but terrifying insight. Earth was not the model. Earth was the variable. Once Mars had been fully mapped, its chemistry catalogued, its geological memory decoded, its biological past reconstructed. The probes used that knowledge as a framework to scan Earth in a fraction of the time. They did not need decades of observations here because Mars had already given them the template. They scanned Earth only long enough to compare the patterns, to confirm divergences, to note anomalies. And what they found would have been striking. A planet overflowing with liquid water, dense atmosphere, strong magnetism, constant biological activity, and billions of organisms interacting at every moment. Compared to the quiet, preserved stillness of Mars, Earth must have appeared ferociously alive, volatile, reactive, unpredictable. Not a fossil, but a flame. And then came the darkest realization. If the probes were searching for fossils of life on Mars, then Earth was not a fossil, it was the living version, a world bursting with the very thing they had been searching for in the remnants of another planet. Which begged the most troubling question yet. If Earth is the living contrast to Mars's dead memory, what does an intelligence do with a world that still contains what the other has lost? As scientists pieced together the probe's behavior across Mars and the rest of the solar system, a chilling possibility rose to the surface, one that overshadowed every previous theory about resources, minerals, or geological interest. The probes were not simply mapping the crust, measuring ice, or sampling atmospheric chemistry. They were hunting for biological signatures. Not life itself, at least not necessarily, but the fingerprints life leaves behind. Organic residues, altered minerals, trapped gases, complex chemical structures formed only through biological processes. For decades, these residues had lain dormant beneath Martian dust and ice, preserved in sediments older than any Earth-based fossil. And the probes, with their precision and patience, had scanned those regions again and again, as if searching for a pattern that only biological systems create. It started with the organic molecules. Human rovers discovered them only recently, fragments of carbon chains in ancient sediments, complex molecules that hinted at a biological past. But long before those rovers arrived, the probes had traced the same sediment layers with uncanny accuracy. Every location where NASA later confirmed organic molecules had been scanned repeatedly by the unknown visitors. The correlation was too perfect to be coincidence, too targeted to be accidental. The probes weren't mapping the planet, they were evaluating specific markers of ancient life. Their scanning behavior narrowed each cycle, focusing more precisely with every pass, as if zeroing in on something that matched a known biological signature. Then came the methane. On Mars, methane appears in sudden, brief bursts, tiny plumes that dissipate quickly under ultraviolet light. For years, scientists debated whether the methane came from geological activity or microscopic remnants of biological processes. But whenever methane spikes appeared, the probe's scanning signatures were present either shortly before or shortly after. The alignment was impossible to dismiss. It suggested two possibilities, both deeply unsettling. Either the probes were detecting methane far earlier than human technology could, or their own scanning pulses were disturbing ancient reservoirs of it, releasing traces from beneath the surface. The probes were not just observing, they were interacting with the chemical remains of a once-living planet, and the deeper the investigation went, the more it became clear that the probes were identifying, isolating and analysing signs of life, with a precision human science had only begun to approach. They targeted mineralised veins where microorganisms could have once thrived. They swept through clay formations where water once lingered long enough for biology to emerge. They scanned sulfate-rich deposits that formed in evaporating lakes. Every anomaly followed the logic of a system designed to search for life, or the vestiges of life within a planet's geological memory. This realization led to an even more disturbing insight. The probes were not searching blindly. They were not drifting through the solar system hoping to stumble upon biology. They arrived with a purpose, a checklist, a method. Their behavior was consistent with the actions of an intelligence that knew exactly what kind of chemistry to look for, exactly where biological signatures tend to accumulate, and exactly how to differentiate organic activity from geological noise. They were investigating Mars the same way biologists examine fossils, looking for chemical footprints that reveal what once lived, how it lived, and how it died. And then came the darkest inference of all. If the probes were searching for signs of ancient life on Mars and found them, what would they conclude about Earth, a world overflowing with active, complex, thriving biology? Mars was a closed chapter. Its life, if it existed, was long gone. Earth, on the other hand, was still writing its story. And that meant the probes had not just been studying Mars to understand its past, they were using Mars to prepare for Earth. The dead planet was the baseline. The living planet was the anomaly. And to an intelligence interested in biology, Earth would be the most important data point of all. Because if they truly came looking for life, then our world was not just part of their mission. It was the answer. As the investigation deepened beyond biology, another pattern rose into view, one that ran parallel to the search for ancient life, but carried its own cold logic. The probes were not only targeting places where life might once have existed, they were targeting places where rare matter accumulated, elements formed only under specific planetary conditions, deposits left behind by ancient oceans, volcanic vents, or meteorite bombardments. Materials so scarce in the cosmos that entire civilizations might cross the void just to find them. And when the Council laid mineral distribution maps of Mars over the paths of the probe's scanning signatures, the picture snapped into place with devastating clarity. The probes had traced almost every major concentration of rare elements on the planet. Not casually, not occasionally, but relentlessly, over decades. The most striking correlations were with boron, an element crucial for stabilizing certain complex chemical structures and extremely rare on most rocky planets. On Mars, boron appears mainly in ancient lake beds, the same regions the probes scanned over and over again. Where humans saw sediment and clay, the probe saw a resource shaped by billions of years of planetary evolution. Their scanning paths passed directly through boron-rich zones, pausing in the exact areas where rovers later detected the highest concentrations. It was as though the probes had been inventorying Mars's chemical wealth long before humanity had even confirmed it existed. Then there was beryllium, a metal rare even on Earth, concentrated primarily in zones of volcanic and hydrothermal alteration. The probe's scanning patterns threaded through every known beryllium-rich formation on Mars, including a few regions where scientists had not yet confirmed its presence. When those areas were tested years later with spectroscopy from orbit, the probes were proven right beryllium deposits existed where they had scanned. The implication was chilling. The probe's mineral detection capabilities far exceeded human technology. They were not searching, they were verifying. Another key target was manganese oxide. found in quantities on Mars that puzzled geologists for years. Its formation requires chemical conditions almost impossible to create without strong oxidizing agents or biology. The probes swept these regions with unusual intensity, sending deep pulses into the crust as though trying to determine whether the manganese formed naturally or through ancient biochemical processes. They treated these areas as crucial data points, scanning them during nearly every cycle. But the most unsettling mineral correlation came from the presence of specific isotopes, variants of common elements altered through cosmic conditions rarely found on stable planets. In particular, regions rich in certain isotopes of iron and titanium showed repeated anomalies in the probe's deep scans. These isotopes are created under violent astrophysical events or through processes not typically found on small planets like Mars. And yet the probes targeted them consistently, as if cataloguing materials that might serve as fuel, catalysts or structural components for advanced technologies. Some areas that showed the strongest scanning signals corresponded to ancient impact sites, craters formed billions of years ago when massive meteorites struck the surface. These meteorites often carried elements forged in supernovae or neutron star collisions materials that are almost non-existent within planets themselves. The probes seemed to know exactly where these exotic deposits were buried, cutting through the dust and rock with beam-like precision. They returned to these locations regularly, as if monitoring whether erosion or shifting sands had revealed new pockets of valuable matter. And as the scientists studied the probe's mineral-focused patterns, a second unsettling truth began to form. The probes were not merely cataloguing resources, they were assessing them. Their scans focused on purity, concentration, accessibility. They penetrated deeper into high-value zones and skimmed the surface of less interesting ones. Their behavior mirrored extraction surveys used on Earth mapping resource potential, identifying valuable sites, calculating feasibility. But if the probes were indeed evaluating Mars's mineral wealth, then what did that imply for the solar system? That it was being appraised, measured, weighed. Mars, with its exposed crust and preserved minerals, offered a clear view. Earth, with its oceans, forests and industries, concealed its wealth beneath layers of noise and complexity. It would be far harder to evaluate, which is why perhaps they studied Mars first. This brought the Council to a terrifying possibility. If the probes were searching for rare minerals, then they might be preparing the way not for an analysis but for a harvest. A mission that begins with mapping always ends with decisions. What to take, what to ignore, what to leave behind. And if they found something valuable on Mars, then Earth, with its richer, deeper reservoirs, would not be exempt. They were not searching for metals, they were searching for reasons to return. As the evidence accumulated, biological remnants, mineral corridors, subsurface voids, atmospheric pulses, and decades-spanning scanning cycles. A grim understanding began to crystallize across the scientific council. Whatever intelligence had been examining Mars was not a passive observer and not a scientific visitor in the way humanity once imagined extraterrestrial contact. Their mission carried a weight, a structure, and a purpose that suggested evaluation, not curiosity, assessment, not exploration. And the more the probe's behavior was reconstructed, the clearer it became that their work on Mars was not meant to remain isolated. Mars was step 1. The solar system was step 2. Earth was the final equation. The probes had gathered data for a reason, and that reason cast a long, cold shadow over everything humanity believed about its safety in the cosmic dark. The first sign of danger came from the sheer consistency of the scans. Nothing in nature behaves with that kind of precision. Stars flare chaotically, dust storms rise unpredictably, planets shift in subtle, irregular patterns. But the probe's cycles followed a machine logic, one that ignored randomness entirely. They operated on a higher order one that treated the solar system not as a landscape, but as a system to be measured, analysed and categorised. Their revisits to Mars were not about checking for changes, they were about verifying stability. Their sweeps of Europa and Enceladus were not about exploration, they were about identifying patterns. Their pass over Earth was not a greeting, it was a final comparison. In the cold, quiet structure of their mission, Earth was not the protagonist. Earth was the last data point. Then came the realization that the probes were testing thresholds. On Mars, they had scanned deep into ice reservoirs, disrupting sediments and triggering tiny methane releases. On Europa, their signatures intersected zones where cryovolcanic plumes erupted. On Mercury, their scans concentrated around rare elements locked beneath a brutal crust. And on Earth, their presence coincided with subtle disturbances in the magnetosphere shifts so slight they were dismissed as ordinary variability, yet precise enough to align with the probe's known behaviour. This pattern resembled stress testing, the kind used to determine how a system reacts under controlled pressure. Mars, being stable and dead, offered data about memory. Earth, being alive, offered data about response. But the most chilling implication came when analysts reconstructed the possible motives behind such an evaluation. There were three and none were comforting. First possibility, they searched for resources. In this scenario, Mars was a geological preview, a test site, a catalogue. Earth, richer and more dynamic, would be the true prize. If the probe's goal was to determine the extraction potential of the solar system, then humanity had been unknowingly living on top of a resource map drawn by something far more advanced, something that might eventually return not with scanners, but with machines designed to claim what they identified. Second possibility, they search for life. Not to destroy it, perhaps to classify it, compare it, or assess its uniqueness. Mars was a fossil. Earth was the active specimen. If this is true, then the intelligence behind the probes already knows that Earth is unlike any world they have surveyed in this system, and that makes humanity an anomaly. Something to be studied, perhaps questioned, or perhaps managed. Third possibility, they search for risk. In this scenario, the probes are detectors, guardians of a larger civilization that monitors planetary systems for emerging threats. Not military threats, but biological or technological ones. Worlds that change too quickly. Worlds that produce signals. Worlds that broadcast. Worlds that might travel. In this framework, Earth's explosive rise in radio emissions over the last century would not go unnoticed. It would trigger evaluation, and Mars, with its preserved fossil history, would serve as the baseline for understanding what Earth was before it became loud. None of these possibilities allow humanity to remain uninvolved. The Council understood then that the probe's mission was not benign. It was not neutral. It was not casual. Their presence was a sign that Earth had been placed under consideration, folded into a process that evaluates worlds based on criteria humanity cannot see, measure, or influence. The scans were Phase 1, the transmissions were Phase 2. The silence that followed was not reassurance, it was the quiet between steps, and that led to the final terrifying question. If their mission on Mars determined that the planet held remnants of life, rare materials, and a geological history worth studying, and if their mission on Earth confirmed that life here is active, complex, and technologically emerging, then what does the next phase of their mission require them to do? As the Council assembled the scattered evidence into a single timeline, a pattern emerged that was far broader and far more calculated than anyone had expected. Mars was not the centre of the probe's mission. It was merely the first tile in a mosaic, one small part of a vast multi-step program that stretched across the entire solar system. The probes did not behave like isolated instruments, nor like explorers drifting from planet to planet. Their scanning cycles, their target zones, their timing, their precision all indicated that they were following an orchestrated plan, a structured evaluation process that treated the solar system as a single interconnected environment. Mars was the beginning because it held memory. Europa and Enceladus were next because they held chemistry. Mercury held rare matter. The Moon held seismic clarity, and Earth held life. Every world contributed a piece to the same puzzle, one whose final shape was now becoming impossible to ignore. The probe's behaviour followed a sequence that felt eerily familiar to the Council, the methodology of long-term planetary classification, not the kind used by human astronomers who categorise planets by size, density, or orbit. This classification was deeper biological, chemical, geophysical, and systemic. The probes collected data not just from surfaces, but from atmospheres, magnetospheres, subsurface layers, even orbital debris. They mapped the solar system the way a biologist maps a cell layer by layer, function by function, interaction by interaction. Nothing was random. Every world was a data point in a structured assessment designed to determine the system's overall profile, and the timelines matched that interpretation perfectly. On Mars, The scanning signatures dated back decades. On the icy moons, the anomalies appeared in intervals aligning with half-cycles of Mars's scanning pattern. On Mercury and the Moon, the probe's footprints matched transitional phases between deep scan cycles, and their appearance near Earth coincided with what analysts now believed was the final stage: comparative evaluation. The probes were not just cataloguing worlds, they were comparing them, measuring how they differed, measuring what each one offered, measuring whether they aligned collectively with the criteria of whoever sent the probes in the first place. This realization led to a more disturbing question: what criteria? The probes did not react to beauty, complexity, or scale. They reacted to biological potential, chemical composition, mineral rarity, atmospheric stability, magnetic interference, and systemic behavior. They were evaluating the solar system not as a collection of individual worlds, but as an ecosystem, a resource zone, a biological archive, a potential threat, or a combination of the three. Their mission was neither casual nor experimental. It was strategic. Even more unsettling was the way the probe's attention shifted across the solar system in waves. Mars was scanned first, repeatedly, intensely, almost obsessively. Once its data had been collected to near perfection, they moved outward to the icy moons. Once the moons were evaluated, they moved inward to Mercury. Once Mercury was assessed, they turned to the Moon, and only after all of this groundwork did they pass near Earth. The sequence suggested a logic: evaluate the dead worlds first, then the silent ones, then the resource-heavy ones, and only then the world that is alive. This pattern is identical to long-range reconnaissance programs used in human exploration. Start with the easiest environments, refine techniques, learn the system, then approach the volatile or dangerous targets last. Humans do not dive into unknown territory blindly. They study its borders, map its features, and only then approach its center. The probes appeared to follow the same methodology. Earth was not ignored, Earth was reserved, and the broader implications were even more chilling. If the probe's mission spanned decades or centuries, then the intelligence behind them was thinking on timescales incomprehensible to humanity. They were not in a hurry. They did not need to be. They had already scanned the solar system without ever being noticed. This was not a first visit. This was a continuation of an older process, one that might have begun long before humanity built telescopes to see it happening. This forced the Council to confront the most unsettling possibility of all. The probes were not mapping the solar system for the first time. They were updating its status, a routine evaluation, a scheduled check, a cosmic inspection repeated across countless star systems. Mars was not their target. Mercury was not their target. Even Earth was not their target. The solar system itself was the target. And that meant the question was no longer what the probes were searching for. It was, what happens after the evaluation is complete? As researchers dug deeper into the oldest telemetry they could find, grainy analog tapes, forgotten seismic logs, primitive orbital readings from early missions, a disturbing realization began to take shape. The probe's presence in the solar system was not a recent phenomenon. It was not tied to the era of modern satellites or the brief windows when humans had the ability to detect their signatures. The scans, the pulses, the anomalies, they went much further back, decades, possibly more. The more archival layers scientists uncovered, the clearer the pattern became. Mars had been watched long before humanity had the ability to watch back. And once the early anomalies were aligned with the newer ones, the timeline formed an unbroken chain, a silent history of observations stretching through generations of human ignorance. The first hints appeared in Viking-era logs, strange sensor blips dismissed as electrical interference. But when those blips were fed into modern filtering algorithms, they revealed faint echoes of the same scanning pulse associated with 3I Atlas and R2 SVEN. The frequencies were identical. The timing matched the earliest Martian cycles reconstructed from later missions. These were not errors. They were the first shadows humanity had accidentally captured, long before it understood what they were. Then came the Soviet data. Old radar frames from Mars 2 and Mars 3 contained distortions that early engineers attributed to dust buildup or faulty amplifiers. Yet when analysts superimposed these distortions over modern scanning maps, they lined up with the exact routes later identified as the probe's signature sweeps. The alignment was so precise that statistical analysis ruled out coincidence entirely. In effect, the probes had been scanning Mars while humanity's first attempts to reach it were still struggling to survive their descent, but the most haunting discoveries came not from Mars but from the Moon. During the Apollo missions, astronauts left behind instruments that continued to send data back to Earth for years. Among these transmissions were microseismic events, tiny, sharp vibrations detected during otherwise quiet periods. For decades, lunar scientists categorized these as thermal pops or micrometeorite impacts, but when the timing of those events was compared to reconstructed probe cycles, a terrifying pattern emerged. Every seismic anomaly occurred during windows when the probes should have been passing near the Moon on their way to or from Mars. The tremors were not impacts, they were signatures, barely perceptible fingerprints of external energy brushing the lunar surface. Even older signals surfaced. Magnetometer readings from Pioneer and Voyager records so ancient they had been archived on microfilm contained faint rhythmic modulations that no natural planetary process could explain. These modulations matched the lower frequency harmonics of the scans seen on Mars and Earth decades later. The probes had been here at the dawn of humanity's exploration, and perhaps even earlier. One dataset, pulled from radio astronomy archives dating back to the 1960s, showed brief and inexplicable drops in background radiation, intensity drops that occurred in narrow frequency bands later linked to the probe's transmission pulses. These anomalies were geographically inconsistent, appearing in observatories across continents at the same precise universal time, meaning the cause was not local. Something had passed between Earth and the sky, obscuring frequencies in the exact manner we now attribute to the probe's scanning signatures. At the time, astronomers labelled them atmospheric glitches. Now they formed part of a timeline that indicated the probes had been surveying the inner solar system long before humanity built satellites capable of detecting them directly. And the most unsettling evidence of all emerged from an unexpected source: geological readings taken during early Mars lander missions. Buried in the noise of soil composition logs were faint mineral disturbances, subtle shifts in chemical ratios that suggested the surface dust had been momentarily rearranged or energized shortly before sampling. These disturbances aligned perfectly with the early probe cycles reconstructed from atmospheric and orbital data. The probes had swept Mars mere hours or days before human instruments touched the ground, altering the soil in ways too delicate to notice at the time, too precise to understand until decades later. The timeline that formed from these pieces was overwhelming. The probe's presence was not tied to modern detection capabilities. It had been consistent, repetitive, methodical, long-term. Mars had been scanned roughly every 17 to 20 months for at least half a century. The Moon had been brushed by their passage at similar intervals. Mercury showed signatures spaced decades apart. The icy moons reflected far-reaching scans timed to align with probe cycles around Mars. This was not a coincidence. This was not recent. This was not accidental. It was a routine, a schedule, a system. And when the Council finally pieced together the entire multi-decade trail, one horrifying realization crystallized above all others. They didn't arrive when Atlas and Sven appeared near Earth. They had been here all along. For years, the scientific community believed that the solar system was too vast, too empty and too quiet for anything to move through it without detection. Humanity's instruments scanned the skies continuously. Its observatories catalogued every significant object brighter than a grain of dust, and its satellites monitored the space around Earth with relentless precision. And yet, despite all this confidence, the probes had slipped through these systems for decades without raising suspicion. When the Council finally reconstructed the full breadth of their activity, the question that loomed largest was painfully simple. How could we have missed something so enormous, so deliberate, and so consistent for so long? The answer revealed a truth far more uncomfortable than ignorance. Humanity did not fail to detect the probes because its instruments were weak. It failed because it had never considered that something might be trying not to be seen. The first layer of this concealment came from the probe's operating profile. Their movements were subtle, their signatures faint, and their interactions with planetary environments carefully calibrated to remain just below the threshold of human interpretation. When they disturbed the Martian dust, they did so gently enough that the resulting anomalies blended seamlessly into natural erosion. When they pulsed the atmosphere, the variations were so slight that scientists categorized them as instrument noise. When they penetrated the crust, the resulting voids were small, symmetrical and hidden, deep beneath layers of rock. The probes behaved with an understanding of planetary systems so refined that they exploited their limitations perfectly. They left traces, but traces indistinguishable from the background chaos of space and geology, unless one knew exactly where to look and what to compare. The second layer of concealment came from humanity's expectations. Scientists search for consistent patterns, strong signals, clear anomalies, signs that stand out. But the probe's signals were the opposite. They were quiet, rhythmic, faint and spaced over decades. Each small anomaly on its own looked meaningless. A radar glitch here, a thermal spike there, a dust spiral in another decade. No researcher in the 1970s would connect a faint electromagnetic pulse on Mars with a microseismic disturbance on the Moon 15 years later. The data was scattered across time, isolated by context, buried in archives built long before anyone imagined that intelligent machines could be scanning multiple worlds simultaneously. Humanity did not lack the data, it lacked the framework to interpret it. The third layer was psychological. Humans instinctively assume that if an extraterrestrial intelligence ever came to our solar system, it would announce itself spectacularly bright signals, large vessels, deliberate communication. But the probe's behaviour was the opposite of every cultural expectation. They did not broadcast, land, or reveal themselves. They entered quietly, scanned quietly, and left quietly, treating the solar system not as a place to visit, but as a dataset to update. Their subtlety was not an accident, it was a design choice. And because humanity had spent decades searching for dramatic signs of extraterrestrial presence, it never considered that the most advanced intelligence might approach with precision, restraint and silence. But the final layer of concealment, the most difficult to accept, was the probe's mastery of the limitations of human technology. They operated in ranges where satellites barely listened. They moved in trajectories that passed through blind spots of orbital tracking. They emitted signals carefully positioned between the noise of solar radiation and the sensitivity threshold of Earth's instruments. They exploited gaps in monitoring the same way a master infiltrator exploits gaps in surveillance systems. Humanity never saw them, because humanity built its detection systems to answer human questions, not alien ones. When analysts finally recognized these patterns, the realization was stark and unsettling. The probes had not evaded detection through invisibility. They had passed unnoticed because they understood us better than we understood them. They knew the noise levels of our sensors. They knew the rhythms of our observations. They knew how to hide inside our assumptions, and they used that knowledge deliberately and consistently across decades. The Council understood then that humanity had never been alone in the data. The probes had been moving beside us the entire time, quiet shadows travelling beneath the threshold of perception, leaving faint, scattered traces that only revealed their significance once stitched together across generations. It was not our failure to observe, it was their success in not being observed, and with that understanding came the most unsettling realization of all. If they chose to remain hidden for so long and revealed themselves only when their evaluation reached Earth, then every step of their mission had unfolded exactly as intended. Humanity did not miss them. Humanity saw precisely what they allowed it to see. As the full scope of the probe's behaviour became clear, the Scientific Council found itself confronting a question far more disturbing than how the probes operated or why humanity had failed to detect them. The question that began to dominate every private meeting, every closed-door discussion, every whispered exchange between astrophysicists and cryptographers was painfully simple, brutally direct, and impossible to ignore. For what purpose does an intelligence evaluate an entire solar system with such precision? The data collected by the probes was enormous in scope: biological, geological, chemical, atmospheric, magnetic. It was not the profile of a planet, it was the blueprint of a system. And when intelligence gathers a blueprint, it does so only for one of three reasons: to understand, to compare, or to decide. The first hypothesis, understanding, suggested that the probe's creators might be studying the natural evolution of planetary systems, searching for patterns, anomalies, or evidence of life forms that emerge under similar conditions. If this were true, then the probes were part of a scientific mission on a scale humanity could barely comprehend. A journey through the galaxy, cataloguing and analysing the variation of worlds across light years. But this explanation began to collapse under scrutiny. The probe's scans were too targeted. their focus too narrow, their precision too high. They examined very specific features: rare minerals, subsurface voids, ancient lake beds, magnetic quiet zones, methane plumes, isotopic anomalies. This was not passive survey. This was active evaluation. The second hypothesis comparison was darker. In this scenario, Mars served as a baseline, the silent record of a planet that once held water, warmth, and perhaps microbial life. Earth was the exception, the anomaly, the outlier in the system. By scanning both worlds with such intensity, the probes could measure how far Earth diverged from Mars's trajectory. They could determine whether Earth represented a rare evolutionary path, something unusual, something potentially valuable, or something potentially dangerous. The probe's behaviour supported this idea. They studied Mars first, then Earth, as though building a before and after model of planetary development. But even this explanation felt incomplete. Their interest in rare matter, in subsurface energy signatures, in geological stability, pointed to motives beyond scientific curiosity. And so, analysts turned to the third hypothesis, the one no one wanted to voice aloud. If an intelligence evaluates a system not to learn from it or compare it, but to determine its suitability, then it is conducting a risk assessment, a resource assessment, or both. The probe's actions mirrored the early stages of an operation humans understood all too well: reconnaissance. Not military reconnaissance in the traditional sense, but the kind that precedes large-scale decisions about use, about value, about threat. Every scan of Mars, every pulse through the crust, every mapping of chemical signatures resembled the preliminary steps of identifying what a system contains and whether it meets certain criteria. This possibility reshaped the entire conversation. The probe's long-term presence suggested patience, not haste. Their quiet movement suggested caution, not aggression. Their precision suggested a mission optimized for efficiency and clarity, not intimidation. But what frightened the Council most was the logical consequence of these traits. Reconnaissance precedes action, not always hostile action, not always destructive action, but action nonetheless. No intelligence scans a system indefinitely without purpose. No intelligence collects billions of data points merely to discard them. And no intelligence evaluates biological worlds without deciding how to respond to what it finds. The Council began to consider what such a decision might involve. If the probes were searching for rare minerals, then their mission might precede extraction. If they were searching for biological signatures, then they might be categorizing worlds by their habitability or infection potential. If they were assessing technological emergence, then Earth's radio emissions, satellites, and growing interplanetary presence would not go unnoticed. And if they were evaluating the solar system as a whole, then the outcome would depend not on human interpretation, but on criteria humanity does not understand and cannot influence. In private conversations, a quiet dread began to settle, because if the probes were indeed part of a systematic evaluation, then Earth's fate was no longer tied to the intentions of a civilization across the stars. It was tied to whatever threshold the probes were designed to measure. And the most terrifying aspect was this: the probes had already completed their scans. They had already sent their data. Humanity was no longer being analysed. The analysis had already been delivered, which meant that whatever decision follows is now moving toward us.